Hello, Calculus fans. Somebody's asking about this question on the discussion board, which I'll answer in a second. But the broader issue is, when do we need absolute values for logs? A lot of people have been asking me about this, so I just want to recap once again. When we first learned about the derivative of logs, we started with the log function. Back then, there were no absolute values. It was just this. If you're starting with the log function, the absolute values would be sort of an unnecessary add-on. But let's draw a picture and make sure we're clear on this. So here's what the log looks like. It has an asymptote right here. So let's draw that a little better. It goes down like this. And that's what the log looks like if you didn't remember. Y equals the log of x. And at any point, like if you're at 4 and you want to know what the slope is, the slope is 1/4. So that's something we proved in Calculus 1. But negatives don't make any sense there because the log function doesn't allow negatives. It doesn't allow 0 either. Okay, then go over here. The 1 over x function does allow negatives. There's nothing that says you can't have a negative. You can plug in -2 and you get -1/2. There's nothing wrong with that. So in this situation, we knew ahead of time that this was positive. In this situation, we do not know if it's positive or negative. The only thing we know is it's not 0. So technically, if you write the log of x plus c, and this is the one situation where you need absolute values, it's not right. You'll be perfectly fine if you're doing the area from like 3 to 7. Because if you're doing the area from 3 to 7, you're not going to get any issues here. 3 to 7, 1 over x dx is the log of x from 3 to 7. So you're going to get the log of 7 minus the log of 3, and absolute values are unnecessary. Now, if you change it to -5 to -2, -5 to -2, it still makes sense visually. There's nothing wrong with that. But if you try to use logs, you're going to get errors because you're going to have a -2 and a -5 here, and that's going to give you an error from your calculator. It turns out that if you take the log of the absolute value, it adds this side to this. So if you want to, this is actually the log of the absolute value of x. And it has all the same slopes. So when you're over here at -4, the slope is -1/4. So it works out that this rule expands beyond. Okay, so the main situation when you need absolute values is when you integrate. The only situation, I should say. You do need those. Okay, now to the question the student asked. If you are solving an equation, an exponential equation like e to the x equals 15, and you take the log of both sides, it is weird to put in absolute values. There's no reason to do that here. It should just be x equals the log of 15. In fact, if you get e to the x equals -7, you should not put absolute values. It's incorrect to put absolute values. In fact, if you try to take the log of both sides, you're going to get error, which is what you should get because this has no solution. So when you take the log of both sides of something, you should not put absolute values because you're actually extending the equation beyond where it should be allowable. Okay, so with that in mind, I have this student's work on this question. So they did a great job. Apologize for using your work here, but they did a great job here. They integrated both sides. They got to here. So notice they did not do the integral of 1 over x. If they had, then they would have needed absolute values. So the log did not appear here. No log of x. Okay, so from here on out, what are we doing? We're solving. So we're in a situation like this, and we're trying to solve for z. So what did they do? They multiplied both sides by -1, which is lovely. They isolated the exponential. And they had 3e to the t minus c. And then they took the log of both sides. Now, in that moment, there's no reason to put absolute values. By doing so, you're actually extending the function beyond it. You're allowing things like this, which we shouldn't allow, because if this is negative, this just doesn't make any sense. Now, the truth is on a test, I wouldn't mark, so the answer should be this, but the truth is on the test, these are the same as long as 3e to the t minus c is positive. So if you were to graph them, they're the same. But the graph of this will include more stuff. I mean, kind of like this. It'll include stuff that shouldn't have been there. So that's why it does not recognize this as a correct answer. On a test, I'd give this credit because over the region, these functions are the same when this is positive. They're just not the same when the one on the left is negative. But I can't really feel like I can call that wrong because it is correct for the values in question. But WebAssign does a compare of the functions, and those functions are not the same. All right, hope that clarifies.